Building on the previous module, which outlined 4 distinct approaches for integrating AI into business application, this specific module focuses on securing the first of those approaches, which was API-based AI integration. Now, to evaluate the available methods for securing API-based AI integration, it is first important to understand the different ways in which well-known LLM providers expose their APIs. And to illustrate this more clearly, let us consider a few examples of integration with either OpenAI or Google Gemini or Anthropic Claude. Let us first consider a baseline setup in which a user accesses an application hosted on one of the cloud platforms such as AWS or Azure or GCP. This backend application or a service consumes AI capabilities from these publicly available models and therefore requires an external integration. Now, for an application to connect to an LLM via API, we must start with a strong identity and access management control. And this typically is implemented through API keys in case of AI integration. These API keys are issued to the application or service when it gets registered to the AI provider. And these keys serve as the identity of that specific application. So each time application or a service sends a request to LLM, it must present this key to authenticate and authorize its access to the LLM. These keys could be configured to restrict access on the basis of specific project or to grant model level access. Thereby, this reduces the blast radius in case the key is compromised. You could also set up usage limits and quotas on these keys to prevent abuse and to control cost. In addition to this, the activity performed using these keys can be logged and monitored to provide visibility into parameters such as the volume of requests coming into the API or the model usage, or any sort of anomalous behavior could be detected through monitoring these keys. Now, because these keys effectively grant access to the LLM resources, they must be secured and protected with mechanisms such as storing them in key vaults. And you could also opt to rotate these keys regularly based on the organizational security policies that you have in place. When assessing end-to-end security of this setup, starting from the user through to the backend service, the communication between user's browser and the backend service must first be protected against common vulnerabilities. This is typically achieved by placing a web application firewall, commonly referred to as WAF, between the browser and the backend service. Or you could choose to route your traffic through a CDN provided by vendors like Akamai or Cloudflare. CDN stands for Content Delivery Network, and they come bundled with a WAF capabilities. This setup provides critical protections such as bot mitigation or DDoS defense, and most importantly it safeguards against OWASP vulnerabilities, thereby strengthening the application's external security posture. In addition to this, you should enforce user authentication and authorization through an IDP, identity provider. You could use a provider such as Okta or Entra ID based on the type of setup that you have. And that now takes care of the front-end security. And for the backend, most of the mature organizations make use of API management layer for API integrations, and hence the API traffic are routed through API manager. This provides more centralized control over the backend security, such as rate limiting the traffic, schema validation, and other API related controls. Now, these AI models could also be integrated through cloud providers such as Azure or GCP. For an example, OpenAI models are delivered on Azure via Azure OpenAI Service, while Google Gemini models are delivered through Google Cloud Vertex AI. Each is hosted and governed by its respective cloud provider and integrated with the provider's native identity, network, and security controls. This allows integrations to be provisioned via the underlying cloud platform. This model can provide a stronger security control, particularly through OAuth 2 based authentication, enabling more robust identity and access management compared to standalone API keys. In summary, the security mechanisms discussed collectively establish a layered defense model for API integration to AI. Users to application. Traffic is protected through WAF, providing OWASP focused controls, and identity providers for authentication and authorization. Backend integrations are governed by API management platform, enforcing rate limits, schema validation, and traffic inspection. Access to AI services controlled through strong identity mechanism, ranging from tightly scoped API keys or OAuth 2 and cloud native identity and access management mechanisms, supported by quotas, monitoring and logging. When combined with secure key storage and rotation and continuous oversight, these controls form a defense in depth approach that significantly reduces risk while enabling a secure, scalable consumption of AI service through API.